Hi, I'm Nathan, and in today's video I'm going to be taking you through how to do conditional field functions in STAR-CCM. So this is to say, if condition is true I would like this, otherwise I would like this condition. And today I'm going to be using it to create field functions for vectors, specifically velocity vectors. And it's going to be if the radius is less than a certain value, which in this case is going to be 13.7, then give the rotational velocity, otherwise I'd like it to be 0. So I'm going straight in here, and this is how you do it in STAR-CCM. So the first thing here is the condition. You have to say if this condition, question mark, and if it is true, then replace true here for the outcome you would like to happen, and if it is false, then the outcome. So here I would like it to be the rotational velocity if this is true, otherwise I would like it to have velocity 0, 0, 0. So as I mentioned earlier, the condition I'd like here is if the radius is below a given value. So I'm just going to do the square root of x times x plus y times y, and this is just how you can do this in STAR-CCM. And then at the minute this isn't a condition, this is, so you have to add here, if the radius is less than 13.7, then give it this velocity, otherwise don't. So one thing that I've found helpful while doing this is, if you see here I've deleted the bracket off the end, which makes it incorrect, and if you see it comes up with a syntax error, which is really helpful for if you've made a mistake. It will come up saying there's a syntax error before you're trying to allocate it to some boundary conditions. And then here you can just see I'm going to plot this field function, and we expect a velocity on the inside of the middle radius, as you can see here, and a 0 velocity on the outside. So that's just what we were after, and you can apply this to many other things to say if this condition is true I would like this, otherwise I would like this to happen. So yeah, I hope this video has been helpful. I'm just showing here how you can then allocate this to a boundary condition. So this is, I would like to say that the wall boundary condition is a moving wall, and I'm giving it vector because the field function we generated was a vector field function. And then you just want to assign this to the field function. As you can see, I had it on inner velocity, but I've changed it here to top bottom velocity. So I hope that's been helpful. Thank you for watching.